All right, so we're going to take a look at factoring polynomials. It's important to note that we've already been factoring polynomials. All of the factoring of quadratics that we've done has technically been factoring polynomials because quadratics are just polynomials, a certain kind of polynomials. For the higher degree functions, though, like cubics and higher, we have a couple of other strategies that we use. Now, in this class, we're going to kind of stick to the third degree. We don't really go too much higher than that. And one of the primary ways we do that is by grouping. Now, it's called factoring by grouping because we separate our polynomial into two groups, the first two terms being the first group and the second two terms being the second group. And what we're looking for is the greatest common factor of each of these groups separately. So what is the GCF of this group and what is the GCF of this group? So what we do is we factor it out. So here the GCF of x cubed plus x squared, that's going to be x squared. Notice they do have coefficients in front of them. It would be technically 1x squared, but they've also got x's in common. I'm going to take as many out as I can. And when I do that, remember that I'm dividing, right? I'm dividing by x squared. And when I do that, I reduce my power. I subtract my exponents. So x cubed divided by x squared, 3 minus 2 is just 1x left. And then when I divide x squared by x squared, I'm just left with a 1 there. Now, it should be fairly obvious here that the greatest common factor of negative 25x minus 25 is going to be 25. I do want to make a note here. If this term is negative, whatever you factor out, take that out as well. Take the negative with it. So I am going to factor out a 25, but here I'm going to factor out a minus 25. When I divide negative 25x by negative 25, I get x. And when I divide negative 25 by negative 25, I get 1. Now what you'll hopefully notice is that these two sets of parentheses are the same. Now, this is a term, and it has x plus 1 as a factor. And this is a term, and it has x plus 1 as a factor. So I can actually factor out that set of parentheses as its own GCF. So I've taken a GCF out and taken a GCF out and created another GCF to take out. So this x plus 1 is going to come out by itself. Okay? And then what's left is the x squared and the minus 25. Now, if you got a really keen eye, you might spot something that we talked about in a previous lesson. This is x squared, which is a perfect square, and this is 25, which is a perfect square, and they are separated by subtraction, so this is a difference of squares, so we can factor that too. The x plus 1 is going to come along for the ride. Remember, when we factor a difference of squares, we have one of them is plus and one of them is minus. And then we take the square root of each piece, the square root of x squared being x, and the square root of 25 being 5. Now, this is a pretty common occurrence. We want to make sure that we're checking to see if we've got a difference of squares once we've factored out that greatest common factor. It can happen. Now, if this is a plus, we're kind of going to be done. That's all we're going to do. If they're not perfect squares, probably also going to be done. But make sure we're checking because sometimes whatever we got left, we can still break that down more. You can see here I've got 3 distinct linear factors. Okay, 3 factors because it's a cubic. Okay, with a cubic function, we can break it down to at most 3 linear factors. All right, let's do one more here. So we've got, once again, 2 groups. Okay, you don't necessarily have to highlight, just identify 2 groups. Okay, we're going to factor out the greatest common factor of each group. Now I know that 4 is common to both 4 and 16, so I'll be factoring out a 4 as well as x squared because they all have at least 2 x's, or sorry, not 2 x's, they at least have an x squared in there. So remember, I'm dividing that out. 16 divided by 4 is 4, and then when I divide my exponents, or my x's with my exponents, I subtract the exponents. X cubed divided by x squared, that's 1x left. And then when I'm dividing 4x squared by 4x squared, all that's left is the 1. Okay. Now 36x and 9, they've both got a factor of 9. Remember that if there is a negative here, I'm going to factor out a negative along with whatever GCF I pull out. 36 divided by 9 is 4. And you should kind of have a feeling of where this is going to go here. 9 divided by 9, now I had a positive 9 and I divided by a negative 9, so this is going to turn into a negative 1. Now, if you do one of these and these don't match, then a couple of things might have happened. One, you might have the wrong GCF. You might have to check to make sure you factored out the greatest common factor. Two, you factored out the GCF incorrectly. That's also a possibility, so check your division. And three, if you factored out the right GCF and these don't match, then you probably just can't factor that problem with grouping. Now, I'm going to check. These are the same. They come out as one of my factors. The remaining two terms are going to drop down as my, other factor. I'm also noticing that once again I have a difference of two perfect squares, and that's going to factor into 4x minus 1. It's going to come along for the ride. Two sets of parentheses, 1 plus and 1 minus. Square root of 4 is 2. Square root of x squared is the x. Square root of 9 is 3. Once again, I've got three distinct linear factors. Okay, I can't have all of them turn into differences of squares, so let's take a look at one more here on this practice page. Once again, we're factoring out GCS from two groups. These don't really have a whole lot in common. 2 and 5 don't share any factors except for 1, but they still have some x's in common. So I can factor out a couple of x's. The 2x plus 5 will remain. Notice here as well, 2x and 5 have nothing in common, so the greatest common factor of there is just 1, so I'll factor out a 1. And then that doesn't change anything inside. Once again, you can see that my parentheses match. That's 2x plus 5 when I factor it out. And then my other two pieces come along, x squared plus 1. Now in this case, I have a sum of squares. A sum of squares will not factor, so I have 2x plus 5 times x squared plus 1, and that is done.